Good evening, everyone. Good evening. Good evening, everyone. We shall start our training. So today we are going to learn about Hazop study. So let's meet the trainer. Mr. Nirmal Kumar, he's working as a principal engineer in process and technical safety for fluids engineering. He has 17 plus years of expertise in operations, projects, and commissioning in oil and gas sector. He has been an integral part of several turnkey projects for fluids engineering for the past year. We heartily welcome you to the session, sir. Thank you for accepting our invite and joining us here today.
Yeah, thank you.
Okay, so we'll be posting the question slide in the chat box. You have questions, you can post it there. And the attendance will be shared only at the end of the session. So please make note, do not comment your names in the chat box. It won't be taken into consideration for the attendance. And also request everyone for your active participation. You can ask all your doubts to sir. We'll have a dedicated session for Q&A from 6:30 to 7. So without further ado, I request Nirmal sir to take forward the session. Thank you, guys.
Okay, thank you. Good evening, everyone. Are you able to view my screen?
Yes, sir.
Okay, thank you. Yeah, myself Nirmal Kumar. I'm working as a principal engineer, process and technical safety. And we will go into the session. Actually, today we are going to start the Hazop session. This is the agenda for the today's session. First, we will discuss about the safety talk about the Bhopal incident, and next we're going to see the Hazop overview of the Hazop, and next is advantages and disadvantages of the Hazop study, and the final we are going to see the Hazop methodology. And the first slide, this is the industries. Actually, when you're going to see this one, first is the food industry, and when you're going to see the second one, you can see this is a power plant. Okay, and this is the oil and gas petrochemical. Actually, why I kept these three slides means first this is the food industry. We are heard about the batch process and the continuous process during the study in the chemical engineering. Normally, in the food industry, there will be a batch process, and if you're taking that oil and gas or the power plant, that will be the continuous process, we can say. Why we are saying that batch process and continuous process? In the batch process, for the food industry, if you take one the reactor or a 5 meter cube, 10 meter cube, that will comes under the process fermentation and distillation process, and it will take some time for the 24 hours or 44 hours. We need to keep it for the fermentations, and next batch we need to prepare. So for the food industry and the pharma industry, we can say it is a batch process. Okay. And for the oil and gas, if you are taking, we are taking the oil from the well, and it is a processing continuously. So this two industry, we can say this is the continuous process. This is the main difference between this batch process and the continuous process. And this is a Bhopal incident. Hope everyone hear about the Bhopal incident. Okay, this is a major incident which occurred in the India. Actually, the incident is a methyl isocyanate storage tank temperature runaway. This incident was occurred in Union Carbide industry. The main is the incident type is the toxic gas release, and it has occurred in 3rd December 1984. It's occurred in India, and it's occurred in Bhopal, the location. And then due to this major fatalities are occurred, this is a 2153. it is not exact value, and more than 2 lakh injuries has occurred. If you want to see the videos, you can afterwards you can see the YouTube that 6 seconds. If you are put Bhopal gas disaster, we are having the 3 videos. You can see it afterwards. Actually, I will explain this what is going wrong in this Bhopal incident. Here we are seeing this video. In this that MIC tank. This is the methyl isocyanate tank. Okay, and this is the VGS as a scrubber. VGS is the scrubber, and third one is the flare. Okay, these are the 3 major equipment you are going to see here. Okay, and what happened? This is the MIC storage tank. I will explain. We will see. And then the carboryl was being manufactured by reacting the methylamine with the phosgene to make the methyl isocyanate. Actually, that methyl isocyanate is the intermediate product, and the final product will be the Sevin. Sevin. This is for the pesticides. We are using this one. The Sevin plant, after being shut down for the some time, it has been started again during the November 1984. But was still running at far below normal capacity. Initially, the plant got shut down before November, and after the November 84, the plant has to be started with the low capacity. They were started on the morning of the incident. That exothermic reaction occurred in the nitrogen purged stainless steel methyl isocyanate intermediate storage tank. The temperature and the pressure in the tank continued to rise until the 40 tons of highly toxic vapors, including the methyl isocyanate and hydrogen cyanide, that were released to the atmosphere via the pressure relief system. I will explain this is what has happened. Okay, this is the MIC storage tank. We are seeing this one, and this was the scrubber, vent recycle scrubber. And third, we are seeing the flare knockout drum tower. Okay, what has happened? The incident is actually the line, because they have shut down the unit and they have kept for the long time, and after the long time they have started the unit with the low capacity. Okay, during the shutdown time, most of that air got contaminated with the line, and it got choked. The vent line got choked, and for dechoking the line, they have flushed that line. Okay, during the flushing of the line, they have not put any blind into that blind for passing that water into the tank. Okay, due to the non-installation of the blind, what happened? That water got injected into the MIC storage tank. Already in the MIC storage tank, methyl isocyanate is there, and water get enter into the storage tank. So that exothermic reaction has occurred by mixing of water and the methyl isocyanate. So the tank got pressurized, and the temperature got vastly increased. And by means of this, initially here, if you are going to see here, we are having the temperature indicator is there, pressure gauge is there. What has happened? The pressure gauge has shown the reading in the panel, in the PLC panel. Operator was able to see the pressure. That pressure is continuously fluctuating. It's around 50 kg, 60 kg, continuously fluctuating. But that operator who is in that unit has not suspected. He imagined that this is a fault reading, but this is the actual reading due to that exothermic reaction. Okay, this was one of the fault in that happened. And how it is controlling this. See, this is the line. This is the pressure control valve. Okay, in case of increase in the pressure, what will do? This pressure control valve will release the pressure to the scrubber, and after the scrubber, it will release to the flare knockout drum. This is the normal process will happen. Okay, first is the pressure gauge, and the next is the pressure control valve will get activated. If there is any problem in the pressure control valve, and the next is the physical protection. This is the physical protection device as a PSV. PSV will get pop, and it will release the pressure to the scrubber, and after the scrubber, it will going to the flare. What has happened? What has happened in the incident is this all the lines are CS line, carbon steel line. Okay, carbon steel line, and it get corroded easily due to the methyl isocyanate vapors. Okay, actually this line all should be the SS line. Due to the corrosion, the pipeline got leaked, and this, due to that, they kept the out of service. The scrubber actually scrubbed whatever the toxic gases coming in the scrubber, that should be scrubbed by means of the caustic. Okay, here we need to maintain the caustic concentration so that it will get whatever that toxic gases will be there, it will be absorbed by means of the caustic. Okay, and after the absorption of this caustic by the scrubber, and whatever that gases will be going to this flare. Okay, what has happened, the scrubber they kept out of service, and also that flare also that kept out of service. Okay, due to that they kept out of service, what has happened, whatever the toxic gases released from here, it has not get absorbed by means of the caustic, and directly that by means of the PSV, that gases has vented to the by means of the flare, it went outside to the community. Okay, it has happened in the community, and whatever the toxic gas released, and most of the peoples outside the unit has got injured, and also the fatality has got occurred because it is the early morning, all has got slept, and this toxic fumes has got engulfed into that whole all over the area. There is no proper emergency management system has been maintained in this section. These are the lessons learned because of this one. Okay, what are the cause? Runaway chemical reaction caused by water ingress into the, as I have said, water during the flushing they have not installed the blind, so water get ingress into the methyl isocyanate storage tank. Okay, and next, what are the critical factors as gets affected? Actually, that methyl isocyanate tank should be kept under the refrigeration system. It should be kept around 20 degree or 20 to 25 degree. But what has occurred? The refrigeration system has kept out of line, so that got pressurized. And then vent gas scrubber also they kept offline, and then flare stack was also not in the service. And the next one is MIC, methyl isocyanate was routinely pressurized out of the tank with nitrogen because MIC tank pump was unreliable, seal leak. The pump, whatever has to pump by means of this one, here you are seeing this pump. Okay, methyl isocyanate tank, this is storage tank, and this is the pump. What happened, this pump has got the seal leak, so they are unable to transfer this methyl isocyanate to the process. So what happened, incoming methyl isocyanate is coming continuously, and water has got ingress into the storage tank. Exothermic reaction has occurred, so the methyl isocyanate tank got pressurized, and the pressurized, actually this PCV has to control the pressure and it has to vent through the scrubber, but this line got choked. So PSV, next action is taken by the PSV, and the PSV get popped, and a scrubber also out of line. So whatever the toxic gases has been released, it is not combustible. It is not combusted. So because the flare is not in line, so all the toxic gases get engulfed into the community. Carbon steel, what I told, the carbon steel vent header was routinely flushed with water to clear the fouling deposit. And another factor also got over the tank temperature, high temperature alarm was disconnected when the refrigeration was system was taken out of service. Actually, the refrigeration system they have taken out of service. During that time, that high temperature alarm also they kept disconnected. If the high temperature alarm has got connected, then they get the alarm in the panel so that operator can take action immediately. And this was, and then next is the emergency water spray was only capable of knocking down vapor cloud at lower elevation. During the toxic gas release, they have started this firewater pump, but that pump unable to catch that top of the location, and then the presence of town near by the area. And what is the main root cause? Inadequate preventive maintenance, inadequate risk assessment. Actually, they need to prepare the risk assessment during the, because the plant was not running continuously, they kept shut down for the prolonged period, and after that they have not done the proper Hazop study. Hazop study is not conducted. If they have conducted the Hazop study thoroughly before starting of the plant, or PSSR they conducted, means this could have been avoided. Okay, and inadequate management of change, inadequate training. As I said, the plant operator was viewing the pressure gauge, and the pressure gauge was showing that actual pressure of 50 kg per centimeter square. But the panel operator was not confident that actual pressure was showing. He is not aware. He thought that pressure gauge was showing the malfunction reading. If he was confident in the process, some is going wrong, then it could have been avoided. And inadequately leadership, inadequate emergency response planning was not proper. Oh, in case of leakage, there should be the emergency response planning should be there. In case of medical should become, and whatever the system, fire water system and ambulance, all should be kept ready so that we can reduce the incident rate. That is not proper. And then this lesson learned is the carbon steel process piping and the equipment is incompatible with the MIC in the atmosphere containing oxygen, because that oxygen has got engulfed with the carbon steel, so that it's got rusted, and then by means of this polymerization reaction, which can cause heavy fouling has occurred. And an inherently safer process for carbaryl manufacture, which avoids production of MIC intermediate. Use the same reactant. This MIC production of MIC can be manufactured by means of the other process. Okay, because methyl isocyanate is having it is a toxic property. Without producing the MIC, we can produce the final product Sevin by means of the other reaction. That in case of the change in the process design, this could have been avoided. And then regulators should ensure the manufacturing companies and made fully accountable for contaminated land and the cleanup cost in the event of spill, because due to that incident many toxic spill has happened, and many releases occurred. This could have been avoided. And a Public Liability Insurance Act was introduced in the year India to provide public liability insurance for providing, because this incident has occurred, and many of the got person's lives has got death, and immediate, and after that act has came, that Insurance Act 1991, and they told we need to provide that relief to anyone by affecting with the hazardous substances. And after that only that many changes in the process safety has came. They have implemented the process safety management. This is the process one. Okay, and what are the main root cause for the incident? That slip blind was not installed. If they have installed the slip blind in the MIC tank, the water should not enter into the tank. Okay, first is that one. And then second is the pressure gauge reading ignored. Actually the pressure gauge was showing the correct reading, it has got ignored. And then temperature measurement, temperature gauge was available, but they made available, they made not provided. Okay, and pressurized tank got pressurized due to the entry of the water, exothermic reaction. And then exothermic reaction, due to the exothermic reaction, that temperature was increased, and even though the temperature got increased, the cooling system they have kept in offline, the refrigeration system also kept offline. If the refrigeration could have been in the line, the temperature will be maintained in that section. And then vent gas scrubber was in maintenance, and then flare was in maintenance. Okay, that's about the incident, about that Bhopal incident. And next we are going to that training topic, origin of Hazop. If you are saying that Hazop is the hazardous operability. This we will say it as a Hazop. Hazardous operability is the Hazop. Okay, this is initially prepared by Dr. H.G. Lovely and Associates of ICI at Wilton in 1960, and subsequently C.J. Bullock and A.J.D. Jennings from CHE Department, Teesside Polytechnic, under supervision of Kells, applied the method at higher institution. And in 1977, Chemical Industries Association published the edited version, and that leaders and experts with a common set of knowledge of the principles of Hazop, according to this is the standard we are using for the Hazop study. International Electrochemical Commission, IEC 61882. This is the standards for the Hazop study. And PHA, process hazard analysis, was legislated in USA as a part of OSA standard CFR 29 part 1910. This was a legislative standard which was in USA, published in USA, and generally that process hazard analysis can be studied by means of the different method. Hazop is one of the method for doing that hazard analysis. Okay, so these are the various method we can identify the hazard. First is the what if analysis. In the what if analysis, and the second one is the checklist, and the third we can do by this hazard, and fourth is that event tree analysis, and this is the failure mode effective analysis, fault tree analysis. Uh, First is the what if analysis. Okay. Okay, what if means what if can be used at any time for the new and existing facilities. This require the experienced team and adequate preparation. Okay, and what if analysis uses the brainstorming session. Brainstorming. Suppose if you assume that the process one in one of the tank amine has been stored by means of the pump. We are circulating that amine to the absorber, and after the absorber, that again that amine is coming to the tank. This is assumed as a process, and by means of the what if analysis we can say this: what if the pump got stopped? Okay, what if the tank got leak? And what if that alarm has not established? What if the line has got leak? Okay, these are the questions we can raise by means of the questions. We can, by means of the brainstorming team will be available by different team like operation, maintenance, safety, instrument, all will be there. So by means of this brainstorming we can analyze the result. So that is the what if method. We can say what if analysis uses a creative team brainstorming, what if questioning approach to the examination of the process or operation to identify the potential hazard and their consequences. We have to identify the hazard and the consequences. And the question that begin with what if are formulated by engineering personnel experienced. The question who is asking the what if, he should be having a thorough knowledge about the process and in the operation. And what if questions, for example, for the piping, if we can say is what if the piping leaks? Okay, suppose if you are saying that what if the piping leaks, suppose the piping in the pipeline some hydrocarbon or gas is moving, we have to identify that what are the causes for the pipe leak and what are the consequences, and whatever the risk ranking we need to identify it. And next we can say is what if the piping support fails? Okay, if we can take any component, if pump we can take is what if the pump seal leak? We can ask many questions. Okay, by means of the questionnaire we need to identify the hazards in the unit. This is a what if study. And then next is the checklist analysis. In the checklist analysis, creative questioning augment the systematic experience-based checklist, provide a more complete study that can be used successfully at any stage in the facility life cycle. This checklist can be used at any stage to identify and evaluate the most common hazard in the process. Okay, this checklist we can do it in that any time. Okay, after the feed stage. After the feed stage, if we are doing the shutdown of the plant, again we are going to start the plant. That we can do in the checklist. Checklist has been prepared by the experienced engineers before starting of the unit. This checklist study we can do it in the middle of the time or before starting of the plant. Anytime we can do it. For example, here the one general checklist study is there. Here we have to the serial number will be there and the category will be a different. Dust blowout hazard adequately addressed. Are there any methods of eliminating or controlling the hazard? This is the response is the response here by the loss prevention team, who is the responsible for this one. Okay, suppose if you are saying that in the category flange bolt gas got properly tightened or not, if we say that response will be done by the mechanical engineer. So that mechanical engineer will check as per the checklist and it will write the command that the action point to be open or close, we have to write it. Okay, this is the checklist method. In the checklist method, different will be there. we can say for the instrument, mechanical, and safety related checklist will be of different for the different department. If you are saying about the mechanical, for the pump, for the blower, or for the pipeline support also is there, we can come. For in case of the instrument, we can say is the transmitter is working properly or not, properly support has given, or high level, low level alarm has been kept or ESD, the ESD valve has been kept in the proper position or not, and then cause and effect function check has been done on before starting the plant related to the instrument. And there are the different department. By means of the checklist, we can identify the hazard and we have to rectify it. This is about the checklist analysis. Okay. And the next is that failure mode effective analysis. In the failure mode effective analysis is done for the specific component. Suppose if you are taking the compressor or the pump, in the pump, suppose the seal got leaked, seal has got leaked. Suppose if you are taking that compressor, the instrument transmitter will be there. In case of failure of the instrument transmitter, what will be the effect occurring in the industry? That means of that is the study. That's the failure mode and effective analysis. This study is particularly done for the single component in the major equipment, analyzing the specific system or the items of equipment that is best handled as objects rather by use of the parameter or operation. Analyzing the pumps, compressor, and the items of equipment having interactive mechanical or electrical components. Okay. FMEA, failure mode effective analysis, consider in a systematic and rigorous manner all of the possible single failure mode of the individual plant item. We need to consider the single failure. Suppose seal leak from the one component, and another standby pump also seal leak, that we can't consider. Is only one pump single failure has to be considered for this FMEA study. And analysis usually carried out by the small team who should have detailed knowledge of the equipment. In the FM is a failure mode effective criticality analysis. The criticality of the consequence we need to identify, and the frequency also addressed and recorded. This is about the FMEA study. And this is the overall about the whatever the PHA process hazard analysis study. These are the differentiate between that Hazop, what if, FMEA, FTA is the fault tree analysis, and the ETA is the event tree analysis study. These are the different study. We will check that whatever. Hazop study is done by the deviation. And I will in the further we will see about what is the deviation. Okay. And what if checklist, by means of the checklist, I have shown the checklist. And if for the FMEA is done by the component, any component leak in the system, we need to study about the specific component, that's FMEA. Fault tree by loss event. Okay. In case of the tank overflow has happened, what is the reason for the overflow? What are the causes that we are going to study in the fault tree analysis? In the event tree analysis, after that leak has occurred, and whatever will be the consequence occurring in the downstream side, that we are going to study in that event tree analysis. After the event occurred, we are going to the analysis. What are the protection is there? That is the event analysis. Fault tree, before that event has occurred, what are the fault has occurred? That is studying by means of the fault tree analysis. Okay. And this is the best. Hazop is best for the process operation, and this is the best for what if is best for the relatively standard operations, and FMEA is best for the mechanical and electrical systems, and fault tree FTA, fault tree analysis, is best for the complex systems, and event analysis to study for one or few causes. Okay. And Hazop study is good for the continuous and procedure based operation, and what if also is good for continuous and procedure based operation. And FMEA, this is for the continuous operations, and FTA is also for the continuous operation for the procedure based. And event analysis is good to analysis what are the controls is available, administrative and engineering control. If you are saying this administrative control, if you are saying this standard operating procedure is there, or any emergency procedure is there, that is comes under the administrative control. If next is this is Hazop is for the higher level. We can see the Hazop and what if checklist are the lower level, and FMEA we can consider as a higher level, FTA higher level, and ETA. And Hazop can analyze complex process with multiple safeguard means we can say what are the protections available in the system, that is the safeguard we can say. Okay. And in the what if checklist, mostly appropriate for this is for simpler operation we can take it. And FMEA, best analysis process with a single point failure, any single component failure we can analyze by means of the FMEA method. This is mainly for the electrical or the mechanical component failure. Okay. And this FTA can analyze complex process with multiple safeguard, and ETA, event tree analysis, can analyze complex for the multiple safeguard. And Hazop distinguish between causes and the safeguard. And what if checklist will not distinguish between the cause and the safeguard. Okay. And FME also does not distinguish between the causes and safeguard. And FTA will distinguish between the cause and the safeguard. And ETA we can distinguish between the causes and the safeguard. Okay. In the Hazop, only look at the causes that could lead to the deviation. Okay. In the what if, only studies causes from checklist. From the checklist, whatever the causes we can identify, that only we can identify by means of what if checklist. And then FMEA looks at all the failure modes of all. Okay. And FTA only studies causing and safeguard related to the top event. And ETA looks at all safeguard protecting against the cause. Okay. Here we are saying the difference between what are the studies in the process hazard analysis. Why we are especially going to the Hazop study in the industry normally means this is the systematic study. By means of that node, we are studying the in the detailed by means of the cause, and we are identifying the safeguard, and whatever the consequence will be going to occur in the industry, we are going to identify. So this is a detailed systematic study, so that only in mainly in that all the industry, oil and gas or anything pharma or food industry, they are doing the Hazop study. Okay. This is a detailed study, systematic study. And if the safety is expensive, okay, why should we invest in the safety? We are seeing this one. Okay. Why think safety is expensive? Because without the safety we can't able to run the plant, because we are because in case of any incident has happened in the industry, it will affect the people, environment, asset, and the reputation. First is the people. Okay. In case of that injury to the people, the company image will be get declared. So we need to check for this. Without the safety is the main priority in our unit, people. And we are seeing the environment. In case of any toxic gas release, it will affect the environment. Okay. So in case of that H2S release means some of the people will get if you consume that H2S gas, they will get faint, it will get injured. Okay. And next is asset. Asset means in case of that suppose any if in the plant there will not be, if you not having the trained operator for in the DCS operation, or in the not having the trained operator in the field, what will happen? In case of any emergency, you need to open or close the wall during the time, similar to time 5 minutes or something. Okay. If it is not opening or closing the wall, what will happen? It may lead to damage the compressor. Suppose in the compressor discharge, one valve is there, suddenly it has been closed or something happen, what will happen? Compressor will got damaged, and it will lead to the injury nearby the people. That is asset. And next one is the reputation. In case of major leak accident like the Bhopal incident, it has happened means the reputation of the company will be more, because we have invested $10 billion or some more amount of money. Okay. It will lost the image. That is about this one. You think that safety is expensive? The today an incident cost about the minimum 10 times, okay, as much it costs to build the plant. Okay, 2 million people yearly die of the industrial accident, because industrial accidents are happen daily. Okay, safety has to run with the process. Okay, this is the wheel. Okay, if we are saying that wheel, na, because it has to be run with the help of the safety, then only we will achieve at the top. Training is the one of the way help people become more aware of knowledge about the safety. Hazardous event. Okay, and what is hazardous event? The release of material or energy that has a potential for causing harmful effect to the personal, surrounding and environment. You are watching, this is the pipeline, this is the steam leak in the plant. In case of any major leak, if you are seeing the plant, we can able to see here this plant. In case of any personal near to that area, you will get affected by means of the leak here. And in case of the major rupture or something, this leak will get aggravated to the community, that is the community at a large, and the environment. In case of any leak, that spill will in case of spillage of chemical or anything, it will go to the environment, so it will affect the environment. These are the three main things. And what are the main hazard in the plant? As we see in the many industries are there, we having different industry, food industry, chemical industry, we can take the oil and gas, and pharma industries are there. Different hazards are occurring in the industry. Okay, this is a common hazard we can see in all the industry. Okay, first is the fire, explosion and toxic release. Fire, in case of the fire, we are having different types of fire. Okay, flash fire, jet fire, pool fire and secondary fire. And the second is the explosion. Okay, explosion will be caused by means of any abnormal chemical reaction occurred in the tank or something. Due to the pressure, it got rupture and explosion will get occurred. uh, First is the chemical explosion, next is the physical explosion, next is the vapor cloud explosion, and the third is the toxic release. Toxic release means in case of H2S or SO2 releases, that will get affect the personal to the personal. So that is a toxic release. These are the major hazardous in the industries, okay, any industries. Okay. What is the belief? Boiling liquid, evaporating vapor, explosion. In the liquid will get boiled, and and it will get evaporated, and it will overflow from the tank. That is the blue. BLEVE, boiling liquid, evaporating vapor, explosion. Okay, that is occurring in the liquid. Blue. We want to know the risk terminology. Okay, in the industries we are generally using the many terms, so we need to know about the risk terminology. Blue. Blue is a explosion caused by the liquid which is boiling and continuously to produce a flammable vapor. Okay, and the next is the combustible. What is combustible? Combustible is a property of the substance that will burn as a result of fire and chemical reaction. Okay. And next, what is the explosion? The explosion is a rapid expansion in volume associated with the extreme outward release of energy that will usually with the generation of high tension. Okay, this is the explosion. And this is a flash point. What's the flash point? Flash point is a minimum temperature at which the liquid give off the vapor within a test vessel in sufficient concentration to form a ignitional mixture within the air near the surface of the liquid. Okay. And uh, we are going, if you are going to see the here, here is one is LEL is there. Okay, LEL is the lower explosion limit. Okay, here UEL means upper explosion limit. If you are taking that hydrogen sulfide gas, okay, for the hydrogen sulfide, LEL will be 4.6 percentage. Okay, and upper explosion limit will be 46 percentage. Okay, suppose in case of any gas leak in the plant, if the suppose if the concentration is 5.6 percentage of LEL, when it will contact with the air, at the time only explosion will occur. Okay, if if the LEL percentage is saying 1%, at the time and it not contact with air, no explosion will occur. Okay, between the range for every chemical we are having the range LEL and upper explosion limit. Between the range is there, by means of air and combustion fuel is there, at the time only that explosion will get occur. Okay, in case of the too rich also it won't cover. Suppose that toxic gas release, it will have in the concentration of the 50% is there in the atmosphere. So at the time also explosion won't occur, because for the explosion minimum oxygen required, and then fuel required. Okay, and then source required. Okay, these three necessary required, then only that explosion will get occur. LEL means the lowest concentration of gas or vapor which will burn or explode if ignited. What is the definition of the upper explosion limit? The higher concentration of the gas and vapor which will burn and explode will ignite. Okay. And hazardous operability study. When to apply the Hazop study? Hazop study can be applied during the feed stage. Suppose if you want to commissioning the plant, that concept initially we are saying the conceptual stage. In the conceptual stage, they will study that whatever the plant, what are the equipments to be done, and what are the cost will be involved to the plant. That and all will be studied in the conceptual study. After the conceptual study, the detail engineering will be done. After the detail engineering, they are going to finalize the P&ID, process and instrumentation diagram. After the finalization of the process and instrumentation diagram, then we can do the Hazop study for the plant. Okay, in this stage we can do the Hazop study, or in case of any modification done in the plant. Suppose if you are taking the example, if you are running the sulfur unit by 50 tons per 100 tons per day you are producing, we need to modify to the 150 tons per day. During that modification, during the modification we require that pump capacity to be increased, line sizing will be increased. So before the modification we need to do the Hazop study. Okay, in the time we need to Hazop study. And next is that suppose the plant is running continuously, many changes will be occurring in the alarm study, or modification has been done in the time. Okay, so what the OSA study, as per the OSA, every 5 years we need to do the Hazop revalidation for the unit. Okay. And what are the advantages of the Hazop study? The range of expertise and experience create a wide information pool base for decision making, and representative from different cultural groups in a facility can bring, because Hazop study is done by the multiple engineering disciplines. So we will get the clear picture and different ideas during the study, and groups can make higher quality decision because they have a greater combined capacity to comprehend the problem's complexity and its alternative solutions. And disadvantages of the Hazop study, we can see the time pressure, because if you are having the plant having the P&ID of 50 P&ID is there, suppose someone will say only 5 days is there, we need to complete the Hazop study. Okay, so time pressure will be there during the Hazop study. And then ego pressure, because in the Hazop study multiple discipline will be there. Okay, one will be saying this safeguard we can take it, another discipline will say no, we can't able to take this as a safeguard, and that's the ego pressure will be there. And it is a responsibility of both participants in the PHA and leaders of PHA team to recognize the negative potential within the group and work towards creating a group cohesion and efficiency. Okay, because multiple teams is there, so all will throw the ideas. So Hazop leader has to control the session, and you need to take into the positive way. Qualitative and quantitative. If you are saying the qualitative and quantitative study, what is the main difference between the qualitative and the quantitative study? In the qualitative study, we can say without the numbers, suppose if you are saying high hazard, low hazard, medium hazard, that will be comes under the qualitative study. If you are saying the quantitative by means of the numbers, we are saying that is a quantitative study. Okay. Suppose if you are saying the quantitative study, we can say the QRA. QRA is the fully quantitative. Okay, 100% quantitative study. And we can, if you are saying that still study, we can say there's a semi-qualitative. We can say semi-quantitative. We can say the still study. Okay, Hazop study, we can semi-quantitative. We can say semi-quantitative. Acid study is quantitative study. Okay, as we see, first is the acid study, next is the Hazop study, next is the SIL study, and this is a QRA study. Okay, QRA is the fully quantitative study method. We are going into the Hazop study methodology. In the Hazop study methodology, we are having the 6 steps. First is the node. What is the node? Node is one. Node is the sections. We can say is the section because when you are saying the plant, from the battery limit, the process will be coming into the tank. From the tank, we are pumping into the distillation column, and after the distillation column, it's going to the scrubber, and after the scrubber, it's going to the final product. So different sections will be there. So we need to mark up in the P&ID the node. Okay, which section we are going to do the Hazop. Different nodes by means of the different color we need to mark up in the process and instrumentation diagram. And after the marking, we need to define the deviation. Okay, deviation we'll see here. What is the deviation? Okay, deviation means no. The deviation is the combination of guide word and the parameter. That is the deviation. Okay, this is the deviation. We can say guide word as a no, less, more. Okay, parameter is the main parameter we are doing in the Hazop study is the flow, temperature, pressure, level. These are the 4 main parameters. Apart from this, many parameters are there. That also we are going to do it. Okay, first we need to select the guide word as a no, and the parameter is a flow. Okay, that is a deviation. If you are combining the no with flow, no flow, that is the deviation. We have to take it. This is a deviation. Okay, and after selecting the deviation, then we have to go for the causes. So we'll say that here will be that also the causes. Okay, if you are saying the causes, causes will be what will be the causes for the no flow in the pipeline. Means we can take the stoppage of the pump is the cause for the no flow in the pipeline. Like this, we have to identify the causes with respect to the flow. First, we need to identify, and next we need to identify the consequences. What are the consequences will going to happen in case of no flow in the pipeline? We need to identify it. And next is what are the safeguards we need to identify. We are saying the safeguards, and safeguards we can say is we can take initial safeguard as a process design is one inherent design, and then next is the basic process control system. First we need to identify whether any basic process control system is there in the system. That is, we can take a safeguard. And next we can take as a alarm. Any high temperature or low temperature alarm is there, then we can take as a safeguard. And after the high alarm, we are having that SIF. What we can say, II. In case of II, ESD valve will get closed. Okay, in case of any II level alarm is there, then we can take it as a safeguard. In case of II alarm is also not working, another safeguard is the physical protection. Physical protection we can say is a PSV, PRV is the, these are the physical protection. Further, in case of physical protection is also not working, and finally we are having this, we are saying this safeguard as a bund valve. In the tank outside, one valve will be there. Okay, that is the protection, further protection in case of overflow of the tank. Okay, these are the safety protection system. I will explain here. This will be clear for you when you're going to understand. Okay, first is the process. If we are saying the process, this is the normal process occurring. Okay, next is the basic process control. Basic, in case of basic process control, the system transmitter, logic solver, and the final element. Okay, these three normally controlling this one. That's the basic process control. And next section is the alarm operator intervention. In case of that, suppose you are taking that water tank or anything, level transmitter with I alarm will be there. Okay, in case of I alarm, operator has to take intervention. That is the operator intervention. Without operator intervention, alarm will going to do nothing. Okay, so that operator intervention we can take as a safeguard. And the next is the safety instrumented system. Okay, safety instrument system is here. I alarm is coming, means next is the II alarm. That is the safety instrumented system. In case of II alarm is coming, that will activate the ESD or shutdown system. That is the SIS. Okay, and next is the physical protection system. That is the relief devices. Okay, in case of any abnormality from the SIS, next protection, what is the protection? Physical protection. That is a PRV, pressure relief valve or pressure safety valve, that will release the pressure to the outside. Okay, and in case of further failure of this valve, what is that? Physical protection we can say is a dike. There's a dike or bund valve we can say in the tank. And next production we can say is the administrative control. We can say plant emergency response. Okay, in the plant emergency response, in case of any leak outside the session, in the plant, the emergency response team should be available. If we say the emergency response team, in the emergency response team, who and all will be there, medical will be there, and the security will be there, and that HR person will be there, and the plant emergency controller will be there. These are the major 4 people will be there during the emergency, because in case of that leak has happened, we need to control the incident within the plant. Okay, we are having the levels of emergency in the plant: level 1, level 2, and level 3 in the emergency system. What is level 1 emergency? Level 1 emergency means within one plant the emergency has occurred is called level 1 emergency. uh, in case of suppose that emergency, level 1 emergency is aggravated, and it is affecting the near and that is affecting the nearby plant, that is called as level 2 emergency. Okay, in case of further leak has occurred, there is a major disaster or anything has occurred, that level 2 emergency will lead to the level 3 emergency. When you are saying the level 3 emergency, that we can say is a community emergency response. At the time that district collector is the controller for this emergency. Okay, this is about the emergency. These are the systems in the safeguard level, you can see. So these are the safeguards, and finally we have to give the recommendations to the Hazop. Okay, first we need to in the Hazop study we need to identify the design intent. What is a design? Design intent is a description of how the process is expected to behave at a node. Okay, this is qualitatively described as an activity or quantitatively in the process parameter. If you are taking one plant, from the one tank is there, pump is there, and the tank is pumping to the absorber or regenerator. Okay, yeah, we have to write the design intent. We have to write that water is pumping from the tank at the temperature of 20 degrees centigrade and the pressure of 4 kg per centimeter square to the absorber. That is the design intent of the node. We need to specifically mention the temperature, pressure, and what is intended to do. That is the design intent. Okay, and what is the deviation? We are saying deviation is in which the process condition may depart from the design intent. Okay, in the Hazop study, we are not challenging the design. Okay, one thing we need to understand that before starting the Hazop study, we need to imagine that plant is running normal, all the safety systems are working properly. Okay, we are not challenging the design in the Hazop session. Okay, only we are identifying the deviation. What are the hazards will going to occur in case of deviation occurring in the plant? That only we are going to study in the Hazop session. Okay, we are not going to challenge the design. We are saying this plant is not designed for the 25 tons per day or something. We are not going to challenge. We can't say that PSV is not designed for that respective tank. Okay, only we are identifying whether the safeguard is there or not. In case of any safeguard is not available, we are giving the recommendation we are providing. We are not challenging the design in the Hazop study. Okay, a deviation is the way in which the process condition may depart from the design intent. Process condition may depart from the design intent. Okay, what it means that depart from the design intent means normally that a continuous flow will be going in the pipeline. What depart from the design intent? We are saying this is a no flow. That is depart from the design intent. Okay, by means of the no flow, what are the hazards will going to occur in that respective node? We are checking this one, and is normally simulated through a combination. This is a combination of guide word and the parameter. Normally the guide word will be no, less, more will be there, and then parameter will be flow, temperature and pressure. Suppose if you are taking as a parameter the level, because commonly level will be there in the tank. Okay, if you are saying the level, then we can say low level. Okay, guide word will be low and the parameter will be low level. Okay, for I level. Okay, like this we have to take the deviation. In case of the temperature, we have to say low temperature or high temperature. No temperature we can't able to say. Correct, na? No temperature is not having the meaning. So we have to take low temperature, high temperature. Okay, for the pressure, we have to say we should not combine that guide word no with the pressure. Okay, we have to take respective guide word with the respective parameter. No pressure we can't able to say. It's having no meaning. So we have to say more pressure. We have to take more pressure or low pressure. Okay, low we can take low pressure or high pressure we can take it. Okay, that's a proper guide word, and the parameter will having the deviation. This is the deviation.
So direct second எடுத்தா வர முடியும்.
Yes, can you deviation? The deviation we can see. These are the deviation we can say. Okay, in case of the parameter, this is the flow. Okay, parameter if you are taking the flow, and design intent we have tried is minimum 20 to 60 meter cube. Okay, this is the minimum is the 20, maximum we can go up to 60 meter cube. That what if they are saying a 20 to 60 meter cube. Okay, and guide word will be the guide word. More we can say more means more flow, and less we can take means less flow. We can say no flow or reverse flow. Okay, for the flow we can take four deviation. Okay, more flow. Okay, more flow means we can say above 60 is a more flow. Okay, in case of more flow, what will happen? In case of less flow, what will happen? In case of no flow means zero flow. Okay, no flow means zero flow, and then reverse flow means it's a negative flow. Okay, it's a reverse flow. Okay, and in case of the temperature, the design intent will be we have to mention what is the operating temperature, 120 to 140 degrees temperature, and deviation is we are saying that high temperature, lower temperature. Okay, we can take it, and no, as I said, the no not having any deviation, so we should not take the no as in the deviation. Okay, and then reverse, there is no reverse temperature is there. Okay, we can say reverse flow is happening in the pipeline. We can't say reverse temperature is happening, so the deviation is not meaningful for the respective temperature as we're taking. Suppose if you are taking the composition parameter, we can say 50 to 60% concentration. Suppose if you are taking the methyl diethanolamine, we can say we have to maintain 50 to 60% concentration. deviation will be more higher concentration. We can say higher concentration of methyl dihydroamine in the process. What will happen in case of lower concentration? What will happen? Okay, as well as we can say for the impurity, and we can say other than means some other because if you are using some other material, what will happen that way. So, and the next is the phase. In the phase we can say liquid phase. Guide word deviation will be the two phase. In case of two phase flow, what will happen? In case of other phase, what will happen? These are the deviations we can consider it. What is a parameter? The parameter is a term through which the design intent, allowable range for a design intent, can be characterized or specified. Hazop parameter can generally be classified into parameters related to input medium properties, parameters related to input medium conditions, and the parameter related to system dynamics or mechanical state, non-physical tangible parameters related to batch. Okay, these are the parameters we can take it. We can say flow, pressure, temperature, mixing, stirring. This mixing and stirring and all that will be mostly coming in the batch process. In the batch process, we can say mixing, stirring, transferring and all. Normally, in the Hazop, these are the parameters, main parameters. It should come. That flow, pressure, temperature, and level will be there. Okay, and viscosity based on the liquid we are carrying. The viscosity. Okay, reactions in the batch process, reaction will be occurring. Composition we can take it. Addition means addition of any chemical. Separation, time, because in the batch process batch process will be running based upon the time. We can say 10 hours that batch should be run. Okay, in case of 11 hours the batch time has been increased. What will happen? That time we can study it. Phase means liquid phase, two phases: liquid phase, solid phase. And then speed, we can say speed, and then particle sizes, measurement, abnormal operations, we can say pH, more pH, less pH, sequence, instrumentation, sampling, and then relief, maintenance, services, communications, operational mode change. Okay, this operational mode change means we are there in the operations in some of the units or plants, we need to run in the flow mode or in the pressure mode. Okay, that is the mode change they are saying. Okay, and normally we will follow in the Hazop will be flow, pressure, temperature, level. This four is compulsory. We are going to study in the Hazop study. Additionally, we can take based upon the client requirement. Suppose if you are taking the if you are doing Hazop study for the pharma company, that will be the different parameters we can take. Like we can take the reaction and stirring and time. We can take it for this one. For normally for the continuous operation plant, we are going to take the flow, pressure, temperature, and level, and then phases we will take, and abnormal operations we are considered for this one. Okay, and guide word we can say no. If you say no, completely stop. Okay, suppose if I am saying the no flow, that pump has got stopped, so no flow. That is a deviation. Okay, in case of more flow or less flow, we can say suppose that in the pump suction strainer will be there. Strainer has got choked, so less flow is occurring. Then we can say it. Suppose in the suction, if you are having any control valve is there, that control valve has opened suddenly, then more flow will be coming. Okay, this is the example for no flow, less flow, more flow. The no flow means completely stop. Tripping of the pump, we will get no flow. Okay, more flow, suppose the pump discharge valve is there, control valve is there for controlling the flow. If the control discharge valve opens suddenly, the level control valve, then more flow we can say. Okay, in case of less flow, the control valve get malfunction and it has got closed, means there's a less flow we can say. The reverse flow, opposite of the design intent. Okay, suppose in case of the pressure difference or suddenly occur in the operation plant, any upsets in the plant, maybe the chances of the flow will be coming to the pump, discharge to the suction of the pump, it will come, so that only this NRV, non-return valve, are installed in the discharge of the pipeline. Okay, reverse flow part of as well as you can take. And other than means complete substitution, we can take it, because if you are said changing the feed with other feed, complete substitution. And earlier, later to the clock, before and after, we can say the sequence. Suppose if you are saying more sequence or less sequence, we can take it. And then too long, considering a required time. Suppose in case of adsorption or absorption process, some cyclics will be there. Cycles will be happening. First will be adsorption, next step will be desorption should be occur. Okay, in case of, there will be a timing should be there. But for 10 for suppose we can say 10 minutes absorption will be occurring, and after the 10 minutes the control has to change the steps mode, and after the 10 minutes desorption should be occur. In case of any change in the timing, what will happen, that is considering a timing, we can say. And these are the main rules for identification. The cause, whatever the cause we are taking, that should be in the similar node. We can't take cause from the other node for the study. Only that cause has to be taken from the identified node, whichever the node we have marked. That only we have to take the causes. Okay, cause means it is something which logically or physically belonging to that node, belongs to the specification section marked on the P&ID released for Hazop. Okay, whatever you have marked in that P&ID respective node, only from that node only we need to identify the causes. Okay, and then consequence can be anywhere, can be everywhere. Outside of the node also it will go, because in the process we are having the different sections. Different sections will be there. One will be absorption, desorption will be there. In case of that absorption, any valve has got closed, the next session, suppose if you are taking the desorption, there the consequence will be occurring in that stage, in that next section only. So we can write the consequences in the first node itself. We can write the consequences. When you are considering the consequences, we should not consider the safeguard. Okay, whatever the final consequences, we need to consider and write it. Without safeguard, whatever the consequences, we need to write it. Okay, and the single jeopardy is applied for identifying the cause. Common mode failure are considered as a single jeopardy. Okay, single jeopardy means suppose one tank is there, and from the tank in the suction, one control is there, that is taking pump is taking, and then discharge, one control valve is there, that is going to any absorber or a stripper, we can say. Okay, in the suction, one control is there, discharge, one control is there. The suction control valve controlling the tank level or flow, it's controlling. Okay, and then discharge also controlling the level by means of the loop. Okay, we should not take for the no flow suction valve also. In case of suction valve also closed, no flow will be there, correct? Now for the node, in case of discharge will also get closed, no flow will be there. So we should not take both the valve as a closed condition in a node. That is the jeopardy, we can say. Okay, we want to take only single control valve has been closed for the causes. Okay, we should not take both the suction and the discharge valve are closed simultaneously. This is the double jeopardy. We should not take in that case. Okay, we should take only one control valve has been closed at any point of time. Okay, that is a single jeopardy. Okay, if you are taking different control valve or closing differently, we can't able to get the proper safeguard and proper consequences in that. And this is the time required for the Hazop study. Okay, this is a TH is the total time to perform the Hazop study. TP is the time to define, prepare, and organize the study in hours. And TS is the time to execute the study via brainstorming session in hours. TW is the time to write the first draft report of Hazop report. C is the constant time report for preparation and writing, and 1 hour for Hazop presentation during the first day, and review the first node. It will take 6 to 8 hours. Um, for the Hazop study, before starting of the Hazop study, we require the process flow diagram and process and instrumentation diagram. Process description should be there, and we need to review all the documents in detail, PFD, PNID, and after receiving the documents from the for the particular unit, what we want to do, we need to mark the different sections for the PNID. If you are taking one PNID, there will be having different notes, 3 or 4 notes will be coming. Okay, we need to mark the notes in the PNID. Okay, after marking the node in the PNID, we need to do the Hazop study for that particular node. Okay, we need to take the causes, and we need to identify the what are the safeguards in that section, and we need to go to the consequences. Okay, and we are having that risk ranking matrix, we need to identify it. Thus these steps and all we are going to see tomorrow. Okay, tomorrow I will explain one process in detail, with the cause, consequences, and safeguard, how we are going to perform. We are going to see by tomorrow. We are going to study in detail, and these are the documents required for the Hazop study: latest PFD, process flow diagram, and process and instrumentation diagram, and operating manual required, relief venting philosophy, cause and effect diagram, and material safety data sheet required, and HMB means heat and mass balance sheet required, because we need to know uh, how much the flow, how much the what is the concentration of H2S or other material. We need to check from the heat and mass balance sheet, and we need to do the know the previous Hazop report. Suppose if you are putting the new plant, and the new plant, there will not be any as previous Hazop report. Okay, so we should not ask for the previous Hazop report. We need to do the fresh Hazop at the time after the feed study. Okay, for the if you are conducting that revalidation for every 5 years, at the time we can refer the previous Hazop report, because when you are referring the previous Hazop report, what are the causes they have taken, consequences they have taken, so we can refer it. Okay, when you are doing the new revalidation Hazop at the time. Yeah, this is a summary. PHA are the methods to systematically determine the process hazard. Most PHA do not examine the worst case scenario. Experience has shown that catastrophic events do not happen, and there should be studies in PHA. The subjective and experience level of PHA team members have a large impact on the effectiveness of the team. Okay. Uh, what overall the team members in the PHA, they should be having a more knowledgeable in the process, and that will have more impact in the hazard identification study. Okay, we are giving the recommendations in the Hazop study. What we are saying, if the because some of them won't accept the recommendation of the Hazop study, what we have to do, we have to implement, we have to write it, and we have to write the reason for the rejection of the recommendation. Okay, because whatever identified in the Hazop session, that will be as a document, it will be there. Okay, and the safety information contained in the Hazop report should be shared to all the employees, contractors. Okay, whatever the Hazop study we have done in detail, and that should be shared to all the employees in the plant, from the top level executives and panel operators, because they need to study the report, and they need to check what are the safeguards is there, and what are the recommendations we had given. They need to know about the hazard analysis scenario. Okay, that's it, man. Yeah, for the today's session, that's it, and we will see you tomorrow. And now we can go for this question sessions.
Thank you, sir, for such a detailed session. So we
Thank
move
you.
on to the Q&A. Before that, I have put the attendance form in the chat. So please mark your attendance if you haven't. And you can ask questions. I'll post the Q&A link once again in the chat. If you have questions, please do ask. Okay, so the first question, what is the difference between Hira and Hazop?
Hira is the hazard identification and risk assessment, and actually PHA Hazop is the part of process hazard analysis. Okay, Hira will comes under the hazards. We can say it comes under the Hazop study, PHA process hazard analysis study. We can say.
Okay, sir. What does it mean by relatively standard operation?
There is a standard operation procedure. If you want to run any plant or anything startup or a shutdown, we need to write the detailed checklist of information in the as a part of the procedure. Okay, suppose if you want to run the pump, we need to check the strainer has been installed or not, and the liquid level has been filled in the tank is not, and power connection is or not. We need to check as a procedure. So this is a standard operating procedure, we can say.
Okay, sir. Is there any tools available to perform each of the method like FTA, ETA, or what if analysis?
Yeah, everything having the software. Actually, for the Hazop, we are using the tool PHA Pro 8. We are using for the Hazop study, and for the Hazop for the other study also, different software is there.
Okay. What is Hazop study analysis?
Yeah, Hazop study, we can say Hazop is a hazardous operability study. This is a systematic study to identify the hazardous in the plant during the normal operation, uh, to find the hazard for the people, environment, asset, and the reputation. This is a Hazop study.
Okay. How do you decide the severity level? Is there any predefined data or we can assume the severity according to the consequences?
No, actually, every company will having the risk ranking matrix. Okay, so based on the company, risk ranking matrix are already identified. So we need to select from that only, because every company, if you are taking oil and gas, that the risk will be different. In case of fire, toxic and release, that will be different. So if you are taking the food industry, there will be a different risk will be there. So based on the company, the risk ranking matrix will be very severity and likely will be vary. So that will be different from the company. We need to take the risk ranking matrix.
Okay. If there is any leakage or incident, will the total plant get shut down or only in the leakage department?
No, that is based on the plant. If we consider the small leak, if in case of any small leak has occur, for the protection in the plant, there will be a detectors is there. Okay, detectors will be there. In case of suppose release the pipeline of amine is leak, rich amine is leaking. Rich amine is having the concentration of around 45%. In case of minor leak in the flanges, in the plant, toxic gas detector will be there. What will do, the toxic gas detector will detect the H2S leak, and it will give alarm to the panel. What the panel operator will do, panel operator will inform the field executive to check the field in the exact location by seeing the CCTV camera where the leak, he will say. So the operator will go and check in that location. In case of minor leak, he will isolate it by wearing the breathing apparatus. Okay, in case of suppose tank has got ruptured, means we need to shut down the plant. That is a major consequence will occur, that fire explosion will occur. Okay, in case of minor leak, we can immediately isolate it, we can run it.
Okay. How Hazop is useful during plant commissioning?
Yeah, during the starting of the plant, we are having we are identifying based upon the hazard, based upon the P and ID and design philosophy. They have already designed. Okay, because at the time alarm, trip, alarm, ESD, and the physical protection devices are already designed. Okay, what we need to confirm it, whether there is any missed during the design stage, any alarm is not there or not, we need to identify it. Suppose if you are taking, suppose the one tank is there, from the tank water is by means of the pump it is going in the tank. If there is only eye level alarm is, they are given eye level alarm, IA level alarm is not there, means what will happen in case of eye level alarm, operator has not taken action, I, IA level alarm is not there. So what will happen? The tank will get overflow. Okay. So during the Hazop study, what we are going to do? We are saying no flow. We will take a cause as a no flow, and we will check what are the safeguard is available. If during this analysis we are checking the safeguard, only IA level alarm is there, IA alarm is not given, means so we can mention the recommendation as IA level alarm to be provided. Okay, by means of this IA level alarm, the ESD will get activated and we can close this one. Okay, this we can do it in the Hazop study. Okay,
Difference between Hazop and LOPA.
yeah. Hazop, we can say semi qualitative analysis Hazop, and LOPA is the semi quantitative analysis. We can say this is Hazop and LOPA. Okay, generally that LOPA will do after the Hazop study. Okay, Hazop is hazardous of Hazop, we can say it's a positive way of thinking. Okay, what we are thinking, we are identifying the causes and we are identifying the safeguards. Okay, suppose if you are taking the cause as a no flow from the pump, cause as a no flow from the pump, what will happen in the tank? No flow means from the tank pump has got discharge. Okay, pump got stopped in the tank, eye level alarm is there, IA level alarm is there. Oh, so you are taking the what you are taking the safeguard in case of no flow, you will write as eye level alarm is there as a safeguard, and then you will write as next is IA level alarm is there as a safeguard. Okay, this we are going to study in the Hazop study. Okay, what we will do in the LOPA study, in case of failure of the IA level alarm, what are the protections is there? In the negative way, we are doing the study. Okay, this is the difference between the Hazop study and the LOPA study. Hope you are clear this one.
Okay. During the Hazop study, can we refer the past Hazop report?
Yeah, we need to compulsory. We need to refer the previous Hazop report. In case of feed stage, new plant is there. There will not be any previous Hazop report. If you are doing for that revalidation for the Hazop study for the plant 3 years running, 5 years, every 5 years you are doing, we should compulsory refer the Hazop report, previous Hazop report.
Okay.
Because if there is having a chances of missing the causes we are taking there, so we need to refer the Hazop report, previous Hazop report.
Okay. In case of safety point view, which study is much more significant, quantity or qualitative study, even though they are entirely different?
We can say quantitative is more of relevant than the qualitative. Okay, why we can say because as this is semi-qualitative, we can say if you are saying semi-qualitative, the semi-qualitative, what we are going to see, we will say high risk, low risk, and medium risk. We can say. Okay, in the quantitative, suppose if you are taking the QRA is a quantitative risk assessment. In the quantitative risk assessment, what we are doing, we are putting the numbers. Okay, suppose in case of pipeline, any leak is occurring, the whole say suppose 3 or 4 mm we are taking in the software, that leak how much distance it will going. Okay, how much distance it will get affected, we are saying by means of that value, quantable quantity value. Okay, so as of quantitative is more better than the qualitative.
Okay. What are the types of risk metrics?
Yeah, we are having qualitative risk matrix, quantitative risk matrix is there. In the qualitative risk matrix, no numbers will be there. Okay, only that severe in the severity and consequences, numbers will be there. One in the severity, one is there, and then the consequence two is there. 1 into 2 6. Okay, already we have defined that one. In case of 6, low hazard. In case of 2, we are getting high hazard. Okay, that is for the qualitative. In case of quantitative, we can say that for the LOPA or a SIL, we are getting the risk matrix as a LOPA, because once in 10 years, we are taking the exact value.
Okay, sir. What is the difference between Hira, Hazop, Hazard, and Hazan?
Yeah, I can say all are the different methods of hazard analysis under the umbrella of PHA, process hazard analysis. Okay, this is one of the study for the hazard study, different hazard study. Okay, this will comes under the hazard analysis study. That's it.
Okay, sir. I think that's it for the questions. Any more questions, guys? Please ask if you have any more questions, or else we can wind up the session.
Sir, good evening, sir.
Good evening. Good evening.
Sir, in risk matrix, how to identify the likelihood with the severity, sir?
Yeah, in the risk matrix, actually, I'm having tomorrow. I will show this one. Actually, in the risk matrix, 1 minute. I will show this one. I will show 1 minute.
Yes.
Are you able to see this one?
Yes, sir.
Okay.
Yes, sir.
Oh, yeah. This is a risk matrix. This is a risk matrix. Okay. As you see on the left side, severity is there. Okay. 1, 2, 3, 4, 5. Okay. With respect to people, assert, environment, and reputation. Okay. As we see here, this is a consequence probability. Probability, if you are saying, has occurred once in an industry or something, by multiplying this two, we will get the risk. Okay. In case of red, is high risk. Okay. This is a low risk. This is a medium. This is high risk. Okay. This is the risk matrix we are following for. This is specific to the company we are following. Okay.
Yes, sir.
Here is the severity. Here we can say probability or likelihood. Okay, we can say probability or likelihood. Multiplication of the severity and probability, we will get the risk. Okay, risk is the multiplication of the severity and the probability. Okay, this is the qualitative. Someone asked, na, qualitative risks. What is that? Okay, this is the one. Okay, severity. If you are saying minor injury, okay, minor injury is going to likely happen. That's a medium. Here no figure is there. Correct, na? Here no value is given. This is a qualitative. Okay.
Yes, sir.
Any other thing?
Any more questions, guys? You can ask sir if you have any more questions, or you can post in the link given.
So good evening, sir.
Yeah. Tell
Hello?
me. Yeah. Tell
Yes,
me.
sir. So you're explaining about LEL, UL, right, sir? So suppose you're choosing any component. So in order to explode of that individual component, it should be around in between the LEL, UL, or it should be beyond the LEL, UL, sir?
No. It should be between the LEL and UEL. Then only it will occur. Okay. Between the LEL, UL. Okay.
Okay.
If there is less than LEL, no will occur. Okay. Suppose above LEL also, nothing will occur. Between that, in case of oxygen get contacted, then it will get exploded.
So if it is beyond UL, it will be assumed that we'll be having an excess of oxygen in terms of fuel, sir.
Yes. Yes. Okay. Because in case of UEL, nothing will happen. Okay. Suppose if you are taking the tank, toxic tank, okay, the tank inside UEL will be there. Okay.
Okay.
Sir, Aravind Mahadevan is asking Hazop analysis.
Yeah. Hazop analysis.
Yeah.
Hazop analysis, I can say Hazop, we are doing we are analyzing the hazard analysis. That is Hazop analysis, we can say. Analyzing the hazard.
Any more questions? Can we wind up the session? I hope everyone has filled the attendance form. You'll be having the assessment of today's module by tomorrow, 11 to 11:30. Thank you, Nirmal sir. Thank you for a great session. I hope all your doubts have been cleared. Tomorrow we'll continue with Hazop session part 2. Thank you. Thank you everyone for joining. Thank you, sir.
Thank you. Any doubt is there, you can post it tomorrow also, no issue. Okay. Today, any doubt, tomorrow also you can post it. I will answer it.
Sure, sir.
Okay.
Thank you.
Thank you.
Thank you,
Thanks.
everyone.
Okay.